Hey guys, welcome to EIKV and this is Vishnu. So in this illustration, the following information of two portfolios given, portfolio D and portfolio G. And here they have given a table. So table containing particulars and details of D and G. So elimination of unsystematic risk over D it is complete and over G it is partial. Now we have the risk, that is diversification risk, which is 6.66 and 14.96. So here the Sensex has given a return an average of 16.25 on the investment in the past year. The expected appreciation in return would be 8% on the return of the previous year. The variance of the return on Sensex is measured as 2.96%. Now 7% of 1000 government face value 1000 government guaranteed bond are traded at 1094. The covariance between portfolio G and the market would be 4.96. You are ascertain the expected return of portfolio D and G. So going ahead with the solution, it would be like I have made a table for the computation of risk-free return. First we need to compute the risk-free return. So first of all we are taking the details from the above illustration, which is particulars, portfolio D and portfolio G. The elimination of unsystematic risk would be complete for portfolio G and partial for portfolio G. Nature of portfolio, efficient and inefficient. So the expected return on the portfolio would be shall be based on, so the computation of expected return shall be based on capital market line for portfolio D and capital asset pricing model for portfolio G. So the formula for capital market line would be RP equals RF plus lambda into standard deviation of P. So formula, for computation of lambda, the formula would be RM minus RF divided by standard deviation of M. So in this formula we can know, first we need to multiply it with standard deviation of the security, and here we need to divide it with standard deviation of market. And the formula for capital asset pricing model would be RF plus beta into RM minus RF. So here in both formula RF is common, which is risk-free return, and then RM, that is return of the portfolio, is also common. Going further, we have the computation of risk-free rate as given in the question. The rate would be 7%, face value is 1000, and market value of the government guaranteed bond would be 1094. Therefore the computation of return in percentage would be 1000 into 7% divided by 1094. That is 1000 into 7 divided by 100 divided by 1094, which gives you 6.39, which is approximately 6.4%. Average return would be 16.25, and after 1 year the return would decrease by 7%. That is 16.25 into 1.08 will give you 17.55%. Now the first computation, expected return on portfolio D, that is capital market line method. So for capital market line method, we have the formula expected return would be risk-free rate into lambda into risk of the portfolio. If there is a mistake here, the increase would be 3%, right? This is not 8%, which is 3%. So the return would be 16.25 into 103, which is 7375, which is 16.4. So going further, the formula for capital market line would be return equal to risk-free return plus market price of risk, which means lambda into risk of the security or risk of the portfolio. So here it would be like 6.4 would be the risk-free rate plus 6.01 is the lambda into risk of the security would be 2.58%. So the final return would be 21.94. So for the computer, first we need to compute the lambda. So for the computation of lambda, the formula for lambda computation would be Rm minus Rf. Here there is a mistake. So Rm, that is return of the market, minus Rf divided by standard deviation of market. So it would be like we need to consider the 3% increase, which would be 16.25 into 1.03 will give you 16.74. Therefore 16.74 minus the risk-free rate, which is 6.4, divided by root of 2.96. So 2.96 would be the variance, which is given in the illustration. I will show you where it is. It has been given over here as 2.96. That is the expected appreciation. The previous year return. The variance of the return on Sensex is measured as 2.96. So the 2.96 root of 2.96 would be taken, and it would be 16.74 minus 6.4 divided by 1.74 will give you a lambda of 6.01162. Now the return will be the risk which is given as 6.66 in the question. That is over here, it is given as 6.66. So it should be taken over here, root of 6.66, which gives you 2.68. Therefore 6.4 plus 6.01 into 2.58 will give you a return of 21.9. Going further, it would be like the second question, that the expected return of portfolio G, which is computed under CAPM, that is capital analyzed pricing model. So the formula would be Rf plus beta into Rm minus Rf, which would be 6.40 plus 1.68 into 16.64 minus 6.4. So it would be like 23.77. Now the computation of beta. So for the computation of beta over here, so you are pretty much curious how the beta has been computed. So that it's been explained over here, the computation of beta. So the complete computation of beta would be the covariance of portfolio G and market divided by variance of the market return. So variance of the market return is 2.96, and the covariance of the portfolio would be 4.96. So 4.96 divided by 2.96 will give you a return of 1.67. So which is taken over here as beta, and the final answer would be 23.77%. So guys, thanks for watching this video. I hope you are clear with this example. If you find this video helpful, please subscribe.